Okay, for today, a quick review of where we went last time. 1 plus I is a complex number. It's complex not just because it's complicated. It's complex because it's got imaginary and real parts. What's the real part? What's the imaginary part? I. And how many I's do we have? One, because there's a 1 in front of the I. Can you graph an I? No, but you can graph in the I direction. Would you please put this briefly, quickly, on a chart, and an XYI chart? Just put a dot. That's all it is. It's a dot. It's a place. And that dot represents rectangular polar. No. There's no such thing. Rectangular what? Rectangular complex. Okay. Did you put the dot equal distances over and up, and therefore somewhere like that? Okay. And then I'm going to say that this distance is 1, right? No. What's that distance? If that's, yeah, if this is a 1 and this is a 1, that must be square root of 2. Okay. Then what do you think I'm going to make next? What form? Polar complex, which is also known as blank form. 3 little letters. Cysts. Could you please put this in cyst form? And now, if it was just squaring, it wouldn't be hard to do 1 plus I and square it. You just do 1 plus I, and you do 1 plus I. Just a second here. And you could multiply it all the way out, and that would work. Okay, but what if we were going to do it to the 3rd power? You'd have to do another one, and that wouldn't be so fun anymore. That's why we're changing it into cyst form. And then there's an awesome little technique called demov. It's all about the move of the exponent. All right, awesome. He's probably rolling over in his grave right now. Taken my beautiful name and then turned it into your own. Well, I guess I should be careful because he might be passionate as a Frenchman about how I'm abusing his name. But anyway, I would like you to tell me what cyst form is up in the front. Let's go with you munching away with your computer that I can't see. I know you're doing math, though, because I've checked. I've got a mirror set up behind you, right on the wall up and behind. Okay, anyway. Okay, so tell me, what was it? Yeah. Oh, so this is the excuse part. All right. Okay, I know. I believe you that you are confused. So let's figure out what we need for cyst form. We need an R and a theta. Would you, sir, help out with the R part? Why? Yes, it's the hypotenuse, also known as the radius, and then that will work square root of 2. Does that make perfect sense to you? Do you get if I have a 1 and a 1 that you should know that this is square root of 2? Okay, awesome. Good. So that's the R part. And then how about the theta part? What do you think that stands for? The number of chickens in Zimbabwe? The angle, yes. Yeah, I thought it'd help. So it's the angle. Good, it's the central angle. And what do you think it is? Yes, but we don't say 45. We say, boom, you can do it after all. Okay, so there is cyst form. And what do I do with that? I use demov. Because if I want to put this out, if I want to put this to the, let's say the 4th, then I need a couple 4s up there so that I can move them. Because it's all about the move of the exponent. And hopefully that is something that you learned yesterday. And what did I just do? I just like I can take the number 5 and put it to the 4th power, I can take a complex number and put it to the 4th power. I just put it in cyst form first, and then it's easy to put in. Now, square root of 2 to the 4th, some people are not going to be able to handle this, some people are, is really 2 to the 2nd, which is 4. Process that for a minute. Would you agree it's a whole bunch of square root of 2's? How many? 4 of them. And so square root of 2 times square root of 2 would actually make 2. And then the other 2 square root of 2's make another 2, and then it's 4. Okay, awesome. So that's just 4. 4 cis 4 pi over 4 is just pi. Awesome. Why was that right on the edge of not working? Yes. Because it can't be bigger than pi. Very good. If it happened to have gone over pi, like 7 pi over 6 or anything just past pi, you'd have to rearrange and say, ooh, no, too big. But this worked. Yay, I've got my answer. And now how is today different? Today is different because we're not doing the 4th power, we're doing the 1/4 power. And you might think that that would be just like the same exact thing, and it's got elements of the same thing. But we need to understand this with normal numbers first, because I know you get, if I say x squared equals 9, that the answer is 3 and -3, right? Can't there be something like that with complex numbers? Yeah. So how did this become complex? It isn't, other than if I said plus 0i. I'm going to pause for a second. So, thank you. So, this is now a complex number, and we can find the square roots of it. Do you get that we will actually, when we do the square root, we will do it to this side, and we'll do it to this side, and that we'll end up getting 2 answers, just like we did a second ago, except you can now start using the complex numbers to get your answers. And so I just was mainly trying to remind you that even if I don't make it complex, let's say it's just that. Do you get it's got 2 answers? All right. Well, if we do the 4th root of something, then there's going to be 4 answers. If we do the 6th root of something, there's going to be 6 answers. When you involve complex numbers, you can get 6 sixth roots of something. So let's go back to this screen. And like I said, if we were going to then do this to the 1/4 power, there would be 4 fourth roots of that complex number. All right, so let's start with a simple one. The one we just did. Except we'll do it to the 4th. Nope, that's what we just did. We're going to say if z is this complex number, then I'm going to say it's z to the 4th equals that. And then do you get to fix that, to get z alone, to solve for z? I'd have to put this to the 4th root. That's how you end up getting to the problem. The problem is, what's the 4th root of this? And there's 4 answers. There's 4 fourth roots of this. Take a wild guess what the first step is in doing this problem. I know you've never done it before. Any thoughts? Yes. Exactly right. Convert to Cysts form. Everybody please. We just did this one a minute ago. If you have a short-term memory or even some notes, you should be able to find out what Cysts form is pretty quick. So, I know you just got here, but try to find Cysts form of this puppy. If you forgot how that works, make a picture. Once you got a picture of where it is, Cysts form isn't that bad. For the person that just arrived, Cysts form would be you start by going over 1, up 1, and then that must be square root of 2 because 1, 1 for these two sides means that's got to be square root of 2. So then it's square root of 2, and then you figure out what angle is. Have you got it already? Row kid, you know how to do this? Or you want me calling somebody else for now? Not 1, because this is r, the radius, and that's not, it's not the 1, 1, 1 triangle. It's the 1, 1 square root of 2 triangle. So you're close. That's it. Very good. Root 2 Cysts pi over 4. Now, because we're putting the 4th root on both sides so that we can solve for z, this will cancel, and I get the 4th root thing. How do I do 4th root of this? Well, look at me leaving a big space inside there. If I want to do 4 answers, do you remember the problems that were kind of like this before? sidestep for a moment. Do you remember this? Sine of 3 theta is equal to 1. And then you go sine of u equals 1. And then you go, oh, I remember this one. Sine is 1. And so where is sine positive? It can't be here and it can't be here. And then I get two answers. And sine is 1. Oh, wait a minute. Sine is 1. Sine's the y. Oh, that's one of these kind of deals where y is 1. And where is y 1? That's where y is 1. And so the answer is pi over 2. So then I say u equals pi over 2. It's just a quick overview for the final there. Do you remember all of this? And then I'd say, oh, u is in there, so you are not done. I got to change the u to a 3 theta. Remember this part? And then do you remember that we have to go plus 2 pi k? Okay. And then what did we do after the plus 2 pi k? That would generate a whole bunch of answers. How did we know when we were done? The thing would kind of keep going until it started repeating itself. All right, so just a quick reminder, how to solve this. We would multiply everything by 1/3, including that. Sorry, my 1/3 got funny there. And then this is theta equals pi over 6 plus 2 pi k over 3. And then you had to keep doing it with k equals 0, k equals 1, k equals 2. It's going to be just like that. Okay, so this problem is that, this problem doesn't have cysts involved at all. But it uses that same process that we used before. Let's see if you can do it. Take a wild guess what I'm going to put right there. Plus 2 pi k. 2 pi k. I forgot the pi. Okay, and then I gotta do the demov thing, which is about demove of the exponent. It's gonna go here. We already did that one. You remember this? Remember how it ended up being root 2 times root 2 times root 2 times root 2, and so that ended up being 4? Remember that? Oh, this is the 1/4 power. Ew. That's not going to be as nice. Then just wait. This root 2, would you agree the root 2 itself could be written as a 2 to the 1/2 power, which is then being put to the 1/4 power, which means it's really 2 to the 1/8 power. Okay. Would you have even had to do that? I actually would have accepted this answer of root 2 to the 1/4. I would have accepted it. But I think you're smart enough to handle if I make it 2 to the 1/8. Okay, and then the demove of the exponent moves on to this part where I put a 1/4 here. And notice that does drop down into the denominator because there's a 1 on top and a 4 on the bottom. So then this becomes Cysts pi over 16. And then one more, I'm going to choose to use a different color and bring this 1/4 down right here and make this into 2/4 pi, also known as pi over 2. And then there's still a k. Whew, that's intense. And we have only begun. That's why I was saying that might be a longish lesson, because there's a lot of steps. At least I got the 2 pi k thing in there. Now I got to say k equals 0 and figure out that answer. K equals 1, figure out that answer. K equals 2. K equals 3, and K equals 4, and well, how many do you want anyway? You know what I'm talking about? You're right. We don't want the answers to go over pi, but that's not how you tell you're done. Well, first of all, if it was the 5th root, there'd be 5 of them. What's this? The 4th root, so there's going to be 4 of them. Does that mean you keep going until k equals 4? No, that would actually be 5 things. Okay, so we don't need the k equals 4. But we do need k equals 0, 1, 2, and 3. There's our 4 cases. Now, we go through, and this is our little term generator. And I think it'd be a little easier to write 2 to the 1/8 for all of them. So I'm going to do that. 2 to the 1/8, Cysts pi over 16. Why did this part drop off? Why is that part gone now, Mr. P? That is correct. You're not the Mr. P I was thinking of, but that's okay. I'm not sure you would have been able to do it. He was very quiet. Okay, how about you, JS? Can you tell me if I had put in a 1, like for this one, then what am I going to encounter that's going to be a problem? Like, it's not going to be super smooth. When I put in the 1, what happens? It does. Well, 1 times anything keeps it the same. So why is this kind of a problem? Okay. The reason it's a problem, I need a common denominator so I can add them together to find out what the angle is. All right, so it's not like it's wrong. I just am not done. That's the problem, is I don't have a common denominator. So, man, you need a lot of stuff in this class, don't you? This is one of the reasons that I did the top 20 to make sure you were okay at finding common denominators for simple fractions. Because if you couldn't do that, then how are you going to do this? And there, it became 8 pi over 16 plus this 1 pi over 16. And that gave me a total of... Now, this is the part where I'm not sure exactly how to show my work on this. I'd like to just erase it and write 9 pi over 16. Have you guys got enough notes written down that I can do that? I'm just going to replace this and this with 9 pi over 16. Is that okay? All right. Because this was 8 pi over 16 and this is 1 pi over 16. Makes a total of 9 pi over 16. Now, is that more than 1 pi? 9/16 is less than 1. So that's not over pi yet. I don't have that problem. But I'm glad somebody earlier mentioned we got to watch out for that. So 2 to the 1/8 Cysts 9 pi over 16. Are you sure you made the right call coming in today? Are you sure you made the right call coming in today? Is it worth it for this? This is a pretty rough day. All right. So, do you want the shortcut to get the next 2? Because I think that would be nice, wouldn't it? Then, how much did this one go up? How much did the angle go up that time? 8 pi over 16. How much do you think it's going to go up next time? 8 pi over 16. How many think it's going to go up 8 pi over 16 again? Yes, it will. So, I'm just going to keep adding 8 pi over 16. 8 pi plus the 9 pi makes 17 pi over 16. Can you just keep doing that? Yes, but you got to watch out. What's the trap? Add 8 pi over 16 plus the 9 and you get 17 pi over 16. What just happened? Went over pi. So then you have to say, ooh, can't leave it that way. You know what I mean? Do you get that that's bigger than 1 pi? 16 pi over 16 pi would be exactly 1 pi. Then the only way I have for you, I mean, there is other ways, but the way I'd like you to do it is the way I've done all the others. Draw a picture of it. Where would 17 pi over 16 be? Well, here's where 16 pi over 16 would be, right? A little tiny bit further. So I'm here. What's the other way to get there? This way. And if this was in 16ths, that should make the other one in 16ths. If this is 17 pi over 16, then remember the whole thing would be 16 pi to 16. 16 pi over 16 to do the whole thing. And it's just 1 less than that, and therefore 15 pi over 16. But it's negative. It was 17 pi over 16, which is here. I said, no, we can't do that because it's more than pi. So then I said, what is this? If we make it in 16ths, it's kind of easy to reason out that it's a lot of 16ths. And how many? Well, if it had been all the way to here, it would have been 16 out of 16. That's why it's 15 pi over 16. But it's negative because it's going in this direction. Wow. Lots of stuff to keep track of. There's so many steps like this, and the math teacher starts saying, oh, they're never going to get this right. There's too many steps to get right. But some of you will. Some of you won't, and it's not the end of the world. But if you want to, if you practice this enough, you could do this. It's not that hard. It's just got a million steps, and you got to get them all right. All right, so what's next? Add another 8 pi over 16. Can I just start with this one and add 8 pi over 16? No. I should take the one above it, okay? With what it was before, I mean. So that was 17 pi over 16. Add another 8 pi over 16 makes 25 pi over 16. 2 1/8 Cysts 25 pi over 16. And where in the heck is that? Can I have to draw a picture? Observer, we're drawing triangles all the time. And these circle pictures all the time. Yes. If I went past 16 sixteenths, did I go all the way? What would all the way have been? 32. It helps me to write 32 pi over 16 here. Would you agree that's the same as 2 pi? And then I can go, okay, well, what 25 would have been like, I don't know. Where would 25 be? Well, this is where 16 pi over 16 would have been. And 25 would have been somewhere in here-ish. Okay, so then I got to go backwards this way. How far? Well, from 25 to 32 is going to be 7. And so this must be negative 7 pi over 16. And I can make sure that that's right by taking my 25 pi over 16, try adding the 7/16 to it, and make sure it actually makes 32 pi over 16, which it does. So yay, I got the last one right. And that's that this has to change into negative 7 pi over 16. Wow. There, that's it. If you understood that, you're done. You know everything. The test is Friday. So that's the good part about having to, go kind of fast. But now we got a lot of days because today's only Tuesday. That means we have Wednesday and Thursday where we can review. So that means I'll be able to slip in maybe one other tweak on how we do stuff tomorrow. But we'll probably have time to grade that lab tomorrow or the next day. And then the test is Friday. Yes. How about this? Would you agree that the original answer was 25 pi over 16? Were you with me there, that it was 25 pi over 16? Would you agree that that's past 16 pi over 16, and therefore down here? Then the only reason I'm trading it out is because I want to go with a smaller negative answer instead. That make sense? Okay. That's right. Yes?
Can you just add the 8 pi over 16 to the negative 16 to get 8 pi over 16?
There's got to be shortcuts. I agree. So what did you just say again? What could I have added to what?
I added 8 pi to the negative 15 pi over 16 and I got negative 7 pi.
Oh, I was thinking if you'd subtract because they're negatives. I think what you're saying is you took this and you added, just like we did before, 8 pi over 16, because that's what we added last time. And you're saying that that ended up working out to the same exact thing. All right. This would be negative 7 pi. Yep, you're absolutely right. It absolutely would have worked. So either way, you got to add 8 pi over 16. And I was thinking that this wouldn't work because it was a negative number. And I was thinking that we'd have to add another negative to it to make that work, but I guess it does. Good catch. So all that means is you're still adding 8 pi over 16, but we didn't have to find this one and convert it. We just had to find this one, and actually the nice part is you didn't even have to convert it because it turned out to stay under pi. I want to warn you on that it won't always stay under pi. It won't, it could turn into negative, bigger than negative pi, and you'd still have to convert it. But in this case, it was extra cool because it saved us a step. You are absolutely right. Okay. Now, this one usually blows people's minds then. This will be the question. Find the 3/3 roots of 1. If I'd have just asked you what's the third root of 1, some of you would have been like, what's a third root? But then the others would have been like, oh, it's got to be 1, because 1 times 1 times 1 makes 1. Well, that's one of the answers, but there's more. There's actually 3 third roots of 1. All right, so would you agree that we did all of the other ones in Cysts form, so maybe we should do this in Cysts form? So who's got a better way to write 1 that helps you find the Cysts? Yes? 1 plus 0i is absolutely right. Whatever you ate for breakfast this morning, keep doing that. All right, and you now are going to have a partner to try to figure this one out. Keep each step straight and all that stuff. So pausing for a second while I get you a helper. To get over this next part, I'm just going to say, if it was like this, 1 Cyst 0 is what you'd get for this. If you draw the picture, you'll see it. Then I'm saying if this is the third power, you're going to do the third root. And don't forget to put something in there. I'm going to pause for a minute. Again, while I give you some work time. Awesome. So if we add plus 2 pi k there, then the next step is the move of the exponent. The move is all about the move of the exponent. 1/3 goes, wait a minute, I put a theta there. That's supposed to be a 0. I apologize, not a theta. So 1/3, and then a 1/3. And then 1 to the 1/3 is awesome because it's just 1 Cyst. And what's 0 divided by 3? It's 0. It's 1 Cyst 0. Again, isn't that the same as 1? Yes. And if you think about it, it should be. The third root of 1 is 1. But there's more answers than that. And that's what the plus 2 pi k thing will give us. If I make this my term generator, I'm going to add 2 pi over 3k, and then when k equals 0, this part will just drop off, and it'll be 1 Cyst 0. 1 Cyst 0. And when k equals 1, I'll stick a 1 in here, and then 0 plus that is super awesomely easy. 1 Cyst 2 pi over 3. Did that go over pi yet? Nope. So we're good. Now I put in another one, k equals 2. And now I'm going to stick a 2 into my little formula. And then that becomes 4 pi over 3. Oop, that's going to be a problem. 1 Cyst 4 pi over 3. How many of the groups caught that that was beyond pi and therefore needed to be fixed? Okay, good. What is 4 pi over 3? Well, I'm going to look at what it looks like. 4 pi over 3 would be like here. That's 3 pi over 3, so 4 pi over 3 is just past it. And then that means it really should have been negative 2 pi over 3. And then the last answer is, by now I hope you figured out that we have been adding 2 pi over 3 each time. So I'm just going to add another 2 pi over 3. And I'm back to, wait a minute, what just happened? I put in a third one, and I got 1 Cyst. I add 2 pi, 1 Cyst 0. I already had that. That's what's supposed to happen. See what I mean? I was only supposed to get 3 answers. I tried to go get a 4th answer. It was a repeat of the first answer. So yay, it's working. Do you think you could do this? All right, well, you get a chance to practice tonight on your homework. Let's have you work out the first homework problem with your partner. And then I'll show you where that is. 12-minute warning. Awesome. Then I want you to start with the end. The last question of the homework is that one. It'll be the more challenging one. Do it while you got a partner. Partners help. 2 heads are better than 1. Especially if you're a Hydra. Okay. Sorry about the bottle knock. Now I'm going to draw a picture of this. You know why? Because I'm trying to find Cyst form. And this is at -2, means over this way, -√2. I don't know what the distance is, but I'm going to call it that distance. And then +√2. And √2, oh, that's kind of a pain. It would have been nice if they were 1 and 1, but that's not how they'll be on the test. We're not going to give you super simple ones. Got to find that third side. A squared plus b squared equals c squared. I gave you a way. Do you remember? Square root, and you square this one, and you square that one. So square root of 2 and 2, I think it's the square root of 4. What is the square root of 4? It's 2. How many of you had 2 before I even said it? A lot of you. Good job. Then this side is 2. And hence, I have the beginning of Cysts form. This is 2 Cysts, and then, do I want this angle? No. Because if I just said 45, I would imply I was over here, but I'm not. So it's not 45. It's not even pi over 4. It's a bunch of pi over 4s, 3 pi over 4. Half the battle is just changing it to Cysts form. Did anybody have that Cysts form? Can you verify that I've done this correctly? Okay, excellent. Thank you. You know I make mistakes, so. All right, I got that. Now I'm supposed to find the 4/4 roots. This is the part. My eraser is really weird looking, but I'm going to clean this up. All I really did first was find Cysts. This is the part where I'm going to do the hard work, and that is plus 2 pi k, put it to the 1/4, and then do the move of the exponent, and then I'll do k equals 0, find an answer. K equals 1, is that enough answers? No, I need 4. K equals 2, is that enough answers? No, I need another one. K equals 3, that's 4 answers. And once you've stuck that in enough times, you'll probably find some of your answers for your angles went over pi. Make sure you fix that, because you can't leave your answer as like 3 pi over 2. Anything bigger than pi, gotta fix it. All right, there you go. And one last thing. If this was the test, you'd want to look at this last line closely. Convert them to rectangular. You have 4 answers that are all in Cysts form, and you'd have to convert them to rectangular. I'm not going to make you do that tonight, but I know you know how to turn Cysts into rectangular. Let's say I had 3 Cysts pi over 6. You just have to draw a picture of it and figure out what the rectangular is for it. 3 Cysts pi over 6, well, it would be like this for the pi over 6, and then this distance is 3, and you got to figure out how long x and y are. Or you can do it this way. 3 times cosine of pi over 6. I could look that up. I could draw my little 30, 60, 90 triangle and figure out cosine of pi over 6, right? Plus I sine. That's the CIS of pi over 6. That would also give me my x and y. If I multiplied this all the way out, or if I just make the little picture. I personally like the picture. You get to make the call. But at the end, you should know how to convert the Cysts form into x plus yi, also known as rectangular form. I'm just going to finish this one because I know some people hate it when I leave problems partially done. So I'm going to go, if this is a 30, 60, 90, then this is the 30, 60, 90, 1, 2, square root of 3. And then I can go x is to root 3, like 3 is to 2. So then I'd multiply both sides by root 3. And x would be root 3 over 2 plus I, and then the y part, you figure out the y the same way. Okay, and y is to 1, like 3 is to 2. Oh, it's just 3 over 2. So it's 3 over 2i. There. That's x plus yi form, also known as a rectangular complex form. If you feel like your brain is being stretched, that's how I feel, and I'm the math teacher, and I do this all day. So, yeah, these are not easy. I get that. Remember, just to clarify, the right answer, this is not the answer for this problem. This is an example of how to change something to rectangular. The actual right answer to this question you can find on your key, but this, what you have here, I can't even erase it now. What you had here, that was the start to the right answer, and then you'll have to do these k equals 0, k equals 1, k equals 2, and don't forget to demov this, move this 1/4 here, and there, and there. Okay. I think that's all I need to teach you for today. Reviewing for the next couple days, but that's enough time I can squeeze in a lab grade in there, and then test Friday. Okay, I just realized I never told you what the assignment was. I said to work on the last problem first. This is the last problem, and there are 3 other ones. So let me show you. Only one of them is as hard as this. There's one other hard one that I want you to do on your own. This one you're doing with a partner right now. Here's the other 2, or the other one that's like that. This problem right here. Problem 67. Okay, so do this question right here, number 67. And then I'm going to cut it down. My first hour is going to hate me, but I'm going to let you not do number 60. You can just do number 58. So there's a total of 3 questions. The very first one you should do is 58. The second one you should do is 67. And the last one you should do is the one you're working on with your partner right now, number 73. 3 problems. That's doable. Since we have 2 days to review, this would be a great time to get some homework graded too. Not right this second, but soon.